But despite its title, the scope of my talk will be much more restricted, especially in comparison with Craig, who just gave us an excellent starting step to this two-day conference. Well, let us begin. The question I'd like to, excuse me, I'm going to speak standing up because there's the screen here. The question I'd like to pose, I'd like to ask in my contribution is, what historical role can we attribute to Renaissance and early modern Aristotelianism? I ask this question from the point of view of the history of philosophy as well as of the history of the sciences. Well, the main reason is this. Renaissance Aristotelianism looks like a sort of in-between phenomenon. It was after the big intellectual revolutions of the Renaissance, and it came before the not less important revolutions in philosophy and in science of the 17th, the late 16th and 17th centuries. And different from Craig's methodology, I will be treating of Aristotelianism as a kind of a style of thinking. And the answer I would like tentatively to propose is the following. The historical importance of Renaissance Aristotelianism seems to lie in the role, although often underestimated, of the upholding of certain important philosophical questions concerning science. Well, because it's my impression that the Aristotelians of this period played a very important role in reflecting on logical, metaphysical, or epistemological issues in a let us say, rationalistic manner. And the case which I would like to take in particular concerns mathematics here, as you see in my title. Well, here's the main question of my talk. And let us reflect, first of all, on what mathematics was for Aristotelianism. Well, mathematics for us, present-day academics would be, first of all, a domain of research. But for Renaissance Aristotelianism, it was rather an object of philosophical reflection and analysis in itself. So it was an activity to be studied, a system of knowledge to be analyzed, their foundations to be clarified. Let us call such an undertaking the theory of mathematics. We have very notable theories of mathematics today. For example, the 20th century philosopher Goethe is a very important chapter in this history of theory of mathematics, as well as histories of mathematics today can also be recognized as a chapter of this long history of theory of mathematics. And such reflections were very much alive, I think, in the Renaissance. The debate, the well-known debate today on the certitude of mathematics, I think, attests to this fact. First, let us recall the outlines of this debate. Well, it rather falls outside the scope of this, the historical scope of this conference, but it was in 1547, in the middle of the 16th century, Alessandro Piccolomini, an Italian, commenced a certain debate in pertaining to epistemology. Piccolomini was a humanist, Aristotelian commentator, and astronomer from Siena. What Piccolomini did was to uphold that mathematical demonstrations, well, what he had in mind were the type of rigid, deductive arguments which we see in Euclid's books. He upheld that those kind of demonstrations were not scientific demonstrations in the Aristotelian sense. His view was taken as novel and provoked reactions from his contemporaries. For example, about a decade later in 1560, the Venetian humanist and mathematician Francesco Barozzi published a refutation of Piccolomini. Now, the question is the following. What were the historical backgrounds of this debate? Or put in other words, how should we evaluate, regard this debate from the present, historically speaking? Well, certain studies have linked this debate to the scientific revolution, but in my opinion, this link seems very weak and indirect. Far more interesting is to consider the problem in the light of traditional theories of science and of mathematics. This tradition of reflecting philosophically on mathematics formed a part of general reflections on the nature of science and of each discipline. It started, one can say, in the works of Plato and Aristotle. It was continued in Arabic and medieval Latin philosophy before Piccolomini's time. There were important presuppositions in Piccolomini's debate which pertain exactly to this epistemological, Platonic and Aristotelian tradition. First of all, there were various Aristotelian theories of what it is to demonstrate. Aristotle's treatise on the posterior analytics, subsequent commentaries on this very important text provided this tradition. There were also Aristotelian theories concerning quantity or mathematical objects. What is, for example, what is this abstract figure which we call triangle, which we use in demonstrations? That kind of objects. But there are also factors, I think, peculiar to the Renaissance. Besides this ancient epistemological tradition, one is the Italian Renaissance of mathematics. Because the 16th century witnessed not only developments in the mathematical disciplines and arts, but also a renewed interest in ancient mathematical texts. Paul Laurence Rose has amply demonstrated how humanist mathematicians from Regiomontanus to Comandino, Clavius, to Viet recovered, edited, translated, or commented on texts ranging from Ptolemy and Euclid to Pappus and Apollonius. One important result of this renewed interest in ancient mathematics was the revival of Proclus's commentary on the first book of Euclid's Elements and the Neoplatonic philosophy of mathematics included in this important text. The third factor, which I would like to mention as the historical background, was the new Aristotelianism, new trends in the Aristotelianism of the Renaissance. I mean more precisely the 15th and 16th centuries. In this period, there were new editions and translations of Aristotle disseminated through Europe with the help of the new technology of printing. There was also a revival of the Greek commentators, and thirdly, there was the important revival of the Averroist commentaries on Aristotle. And Craig, in a recent article, has interestingly demonstrated that revival of Greek commentators and revival of Averroists were linked in a certain way. So these, I think, were the historical backgrounds of the debate on the certitude of mathematics. So we can see that the 16th century if we look closely, a very active period in which people, based on mostly Aristotelian epistemological and ontological notions, debated, considered what was mathematics, well, what it is to do mathematical research. Well, finally, I would like to mention in this connection the role of the Society of Jesus, which is one of the main topics of this our conference here. We have just seen how the debate on mathematics in the 16th century, which Piccolomini instigated and other philosophers of the period participated, we have seen how this debate was shaped by historical factors peculiar to the Renaissance. It was the Society of Jesus which inherited this Aristotelianism, and not a small number of their members took interest in problems of belonging to the theory of science and theory of mathematics in particular. Now, let us recall what the nature of the Society of Jesus as an intellectual institution, because despite despite ideas of this society we might form from their role in for example, the condemnation of Galileo, the society was by no means reactionary, still less an anti-intellectual society. They, in establishing an innovative educational system, promoted actively higher learning among its members. Of course, one of the main reasons was the importance of the missions, their missionary role in propagating Catholicism in Europe and all around the world. Well, true, they were obliged allegiance to Aristotle and to Aquinas, and this allegiance was fortified by a system of censorship. But we must not be deceived by appearances, because, for example, studies have shown that censorship was not very effective in imposing a uniformitas doctrinae, uniformity of doctrine. Jesuit natural philosophers of the 17th century could very well discuss heliocentrism in order to refute it. And of course it is well known that the Society of Jesus played a very active role in the transmission of scientific ideas to the Americas and East Asia. Now, what can we say about philosophy of mathematics in the society? Well, in a word, I think their philosophy of mathematics, their way of regarding the science of mathematics, the sciences of mathematics, displays a surprising diversity. It is true that they never rejected fundamental Aristotelian concepts such as form, matter, substance, potentiality, actuality. That sort of conceptual framework was very much alive. True, they also had a hierarchy of the sciences in which mathematics usually came last. Metaphysics came first, of course. But within these confines, their positions on mathematics, I think, display much the same diversity as in, for example, in medieval Aristotelianism. Well, for one thing, we have to note that the Jesuit mathematicians vigorously defended the dignity of mathematics. There's the example of Clavius and Biancani, one of his disciples at Parma. But it is doubtful if they ever could understand the deeper philosophical issues which Piccolomini evoked in his work on the nature of mathematics. But there was also diversity among the philosophers too. Some agreed with Piccolomini. They refused to accord mathematics the status of science in the exact Aristotelian sense. These were, for example, Benito Pereira, and commentators in the Jesuit College of Coimbra in Portugal. But others recognized mathematics as legitimate sciences, such as I only know the examples of Toledo's, Francisco Toledo and Pedro da Fonseca, which Greg mentioned also in his talk just now. Their points of view do not differ much from points of view in Averroes, Grosseteste, Albert the Great, and Thomas Aquinas. In a word, at least concerning the Jesuits of the 16th and early 17th centuries, they did not uniformly criticize mathematics as, for example, being non-sciences. Let us conclude. Let me conclude my brief talk. So we can say that there were various Aristotelian philosophies of mathematics during the Renaissance. We recall Charles Schmidt's famous description of Renaissance Aristotelianism as being Renaissance Aristotelianisms in the plural. The same thing can be said for philosophy of mathematics in the period and also in the Society of Jesus. Well, in fact, that's the point of commenting on text. You have to differ from your neighbor, or else there's no meaning in commenting on Aristotle. And it is true that a theory of science made an entirely new start in the 17th century with people like Galileo, Descartes, Locke, and Leibniz. They had new theories of matter, new theories of mind, new theories of perception. Necessarily, their conceptions of science was entirely different from their counterparts in the 16th century. But as I said in the beginning, I think the contribution of Renaissance Aristotelianism to history seems to be of a different nature. They were transmitters of a tradition, transmitters who, transmitter, is that a good English word? Of a tradition, of a critical tradition, stretching back to the works of Plato and Aristotle, going on through the 17th century, through Kant, up to present-day critical theory and phenomenology. These critical and rational reflections on what scientific knowledge is, in this big tradition, I think, in this long tradition, I think Renaissance Aristotelianism did play an important role. That's it. Thank you.
Thank you so